Okay, so this part is the last part for our chapter 9, also our Pure Max 1, so which is volume of revolution. So finish this part, then we already done with our first paper. Okay, so I'm going to do like comparison between the area under a curve and volume of revolution. So it's basically actually the concept is still the same, meaning you are going to check like whether the curve is the area or the volume that you are finding is actually between the curve and the x-axis or the y-axis and is rotated about the x-axis or the y-axis and to get your answer. Okay, so for the last time we have these notes which is for area that is enclosed by the curve, the x-axis and the line x equals to a, x equals to b, and this is how we find the area, which we will put dx, then after that in front of it is y. So if you have something that is the curve and the y-axis and the line y equals to a and y equals to b, you are going to put like x dy. Okay, so for volume of revolution, you have two parts also. So the first one is the area enclosed by the curve y equals to fx, x-axis, the line x and x equals to a and x equals to b is rotated about x-axis through 360 degrees. So it's going to be like the same thing when we talk about the area for this part. Okay, so I'll try to draw, like for example, we have this line, which is y equals to fx. Okay, then of course this will be our shaded region here, which is a and b. X equals to a, x equals to b. So this is actually the area enclosed by the curve, the x-axis, the line x equals to a and the line x equals to b. So this area going to be rotated about x-axis through 360 degrees, meaning at this part it's going to be rotate at your x-axis 360. Okay, so can you try to imagine if you have this area and it's trying to rotate, right? So it's going to be like, if this is the line, so this is your area, so it's going to be like rotated something like this. So it's going to be like rotate. So what you can imagine is, let's say, of course, if this is my area, then of course I have this line. Okay, so this thing going to rotate about the x-axis, meaning that it's going to be like rotating, and the same thing happen here, is going to be like rotating. Have something like this. Okay, so this is like how it is rotate. So this is will be my A, then this will be my B. So after I rotate, I will be getting something like this. Okay, so how am I going to get the volume of this? Is by using a formula y v, then the same thing, but you have a pi here, and then the same thing like you have things like this. So this is rotated about x-axis, so you are putting dx. So when you put dx, normally for area you will put y, right? But for this case we are going to put y square. Okay, as long as it's rotated about x-axis, then it's going to be y square dx. So the limit is still going to be the same from a to b. So this is the first part, which you have an area that rotated about x-axis through 360 degrees. Okay, so now let's see the second part. So this is the area enclosed by the curve y equals to gx. The y-axis, the line y equals to a and y equals to b is rotated about y-axis through 360 degrees. So the same thing, I'm trying to draw this line. Okay, so this is my A, this is my B, this is my shaded region, and I have y equals to gx. Sorry, x equals to gy. So now this area enclosed by the curve, the y-axis and the line y equals to a, y equals to b is rotated about y-axis. So it's rotated here 360. Okay, meaning that if this is my y-axis, I'm going to be having this curve is like rotated like this. So it's like, this is my line, it's going to be like here, then rotate like this. Okay, so what is the kind of the shape that I'll be getting. So of course we start with this line, then I'll having this line also. When it's rotated, meaning here it's going to be rotate like this. Okay, same thing happened to here. Okay, then I'll be getting a shape like this, which this is my B and this is my A. So this will be my shape. So same thing, how are we going to write the formula? Then it will be the same thing. You have a pi, and then since this is dx, so this is going to be dy because it's rotated about y-axis. So when you write dy, then you will be putting x squared. So the same thing, your limit will be from A to B. So this is how we write. Okay, so something special about volume of revolution is, you remember, for area part, actually we have like, if you talk about this one, then we have negative and positive, and this one you have negative and positive also. But for volume, you can just remember, because for your function, no matter what is your function, you are going to square. So that's why for all the volume here that you find out from the integration will be always positive. So it's like when you do integration for volume, if you get some negative number, then you know that it's something wrong already. Okay, so volume will be always positive only. Okay, so now finish introduction. So basically you just remember is when it's rotated about x-axis, then you put dx and then y square, and don't forget you have a pi before that. Then after that, if you have rotated about y-axis, then you are putting x squared dy. Then after that, again your pi, and then for this case you don't have something like area that you need to differentiate whether it's positive or negative. For all volume is going to be positive. Okay, so now we'll be moving forward to some examples. So let's start with a very like easier example first. So I'll be putting the notes here, so if it's possible, then you try to copy down everything and try to understand everything before you go to the question itself. Okay, so question 1 is going to be the area enclosed by the curve, the x-axis. Okay, the x-axis, and then the line x equals to 1 and x equals to 3, and it's actually rotated through about your x-axis. So for this one, it's basically your scenario 1. Okay, so how do we find the volume here? So since it's rotated about x-axis, so we are going to put dx. Okay, so when you put dx, you are going to write y squared, and don't forget you have a pi. Then after that, what is the limit? From 1 to 3. So now you can start to substitute the value that you need. Pi 1 over 3. So what is y squared? So your y is 1 over x, so meaning 1 over x squared. So dx equals to, and then pi 1 over x squared, which we straight away x negative 2 dx. So when we do integration, then we will be getting negative 1 over x. Okay, divide by negative 1, and then your power is negative 1, so become 1 over. Then 1. So now you can start to substitute. You are putting negative 1 over 3 to minus negative 1 over 1. Okay, so negative 1 over 3 plus 1, which will give you 2 over 3. So in this case, you have a volume of 2 over 3 pi. So this is your answer for A. Okay, it's quite easy actually, just follow the formula. Okay, so for the second one, you can see it's a curve that is normally, when we look at area, then you will say that this is a negative, but don't forget for volume we don't have any positive and negative. So as long as you are finding the volume, then you just do it like normal. Okay, so for this one, it's going to be volume equals to, so this is rotated about y-axis here, so it's going to be differentiate dy. Okay, so when you write dy, then you are putting x squared, and don't forget your pi, and then what is your limit? From 0 to 3. Okay, so remember when it's rotated for about your y-axis, right, the limit that you get should be like on your y-axis itself. So instead of using this, because when using this you are finding rotated about the x, so this is about the y, so your limit is like 0 to 3. Okay, so equal to, so now you need x squared. So since y equals to 1 over 3x squared, then what does that mean? So meaning y equals to 1 over 3x squared. So basically x squared will be equals to 3y. Okay, then you can just stop it here. You don't need to find x. So because it's just that like when you substitute here, then you are still getting 3y after that. So pi 30 x squared is actually 3y, so 3y dy equals to pi. Then start to do your integration y2 30. After that you can start to substitute. So 3 2 3 2 minus 3 2 0 is going to be 0 lah. So your answer is just 3 square, you get a 9. Then after that 9 times 3 you're getting 27 over 2 pi, which is, if you want to change it to mixed number, then it will be 13 1 over 2 pi. Okay, so these are the two examples. So let's move on to the next one. Okay, C. So if you have something like this, okay, so this is rotated about your x-axis also. So again, this is not area, so when you do this type of question, you just solve it like normal, just do it together. You don't need to separate your positive and negative, because the number that you will be getting will be positive always. Okay, so when we do this, then it's the same thing. Volume equals to pi. Okay, so this is rotated x-axis, so that's why dx, then you write y squared. So your limit will be, so just now like what I said, you don't need to separate it, so you can straight away take from the beginning to the end. So but you must make sure that the area that actually they shaded here is like the area between your curve and your x-axis lah. Okay, so from here is like 0 to 3, so you can straight away lower limit, upper limit. Then after that you can get your answer. Okay, so pi 30. So what is your y square? So for this case, this is given in y, so meaning the function we will need to square it. Okay, equals to pi 30. After that, expand it. Okay, we start to do your integration. Okay, 30. I can substitute. With 3 first. Okay, so since it's 0, you better check whether you get everything 0 or not. So 0, 0, 0, so it's totally fine. So minus 0. And then pi. Okay, so when you add up everything, you should be getting 1, 2, 3 over 3. Over 5, sorry. Okay, then after that change it to mixed fraction, so 24 3 over 5 pi. Okay, so that is your answer for C. Okay, it's going to be no ink. Okay, so for D, so let's move on for this question. Okay, so for this question you can see it's actually a graph that is symmetrical about the x-axis. Oh, I'm sorry, I left all this. So this is rotated at your y-axis. Okay, so same thing, we start with V. Okay, so for this question you have 3 choices here. You can actually do, I'm sorry, this is something wrong here. Okay, so yeah, the shaded part is actually here. This is nothing. Okay, so the shaded part is actually here. This is something that I draw it wrongly, I think. Okay, so for the V part, yeah, So you have two choices here. You can see like the area here is actually the area here. The area here is actually the area here because it's asymmetrical. 2, negative 2, negative 3, 3 like that. So you have two choices here. Either you want to straight away do negative 3 to 3, or if you want to do 2 times the limit 0 to 3, you will be getting a same answer. Okay, so maybe we try to do the 2 times, then after that we trying to compare our answer with like negative 3 to 3. So meaning I'm separated into 2, I'm doing the upper part, then after that I'm going to times 2 with my answer. So that's why I'll be doing 2 pi, and then I'm only seeing the upper part, so 0 to 3, and then this is about your y-axis, so it's going to be x squared and then dy. Okay, so equals to 2 pi, and what's my x squared? So y squared equals to x plus 4, so meaning x equals to y squared minus 4. So 3, 0, then y squared minus 4 squared dy. So 2 pi, then let's expand this. If you don't want to expand, you want to do composite also, it's fine. So it depends on which one you prefer lah. Okay, so at y4 minus 8y squared plus 16 dy. Okay, then now you can start to do integration. So y5 over 5 minus 8 over 3 y squared, sorry, y cubed, and then plus 16y. Okay, then after that 3, 0. Okay, equal to, then I continue to do that. So 2 pi, so you substitute your 3 inside. Okay, so when you substitute 0, you check and see whether you get everything 0. If yes, then meaning straight away minus 0 lah. Okay, equals to, then 2 pi. So what you will be getting here is, I think you will get 24, 3 over 5. So when you times 2, you will get 49, 1 over 5 pi. Okay, so if you want, you can try it out. If I try to do v equals to pi from negative 3 to 3 and then x squared dy. So it's going to be the exactly same step. It's just like here you will be substituting negative 3 instead of 0. Then after that, I think your last step will be like 24 3 over 5 minus negative 24 3 over 5. Okay, because like when you sub negative 3 and all of your power is going to be a odd number, so that's why you're getting all the values same, is just like become negative. And then when you have this, then when you plus them together, you are getting 49 1 over 5 pi also, which is basically the same. But this one is like easier because when you sub 0, then you get 0. You don't need to do work out for a negative 3 part. But for this one, you need to work out for a negative 3 part. So it depends on which one you prefer. So it's totally fine. You're getting the same answer. Okay, so move on for the next question. Okay, example 2. Find the volume when the shaded region is rotated through 360. Okay, so let's start with A, about y-axis. So about y-axis means that it's basically like this. Okay, so about y-axis, then you check whether this shaded region is something that is your curve, and then the y-axis, and then you have the limit 5 to this one. I don't know what is that. So this is basically like you don't have the other line or the other curve. Is actually the easy way, meaning that this area is actually bounded with a curve, your y-axis, and then the limit from 5 to this number here. So we need to find out what is the value that we are going to put at the upper limit. So this is like a negative maximum quadratic graph. So y equals to 9 minus x squared. So when you rewrite this, you will be getting your c as 9. So that's it. That is how we know that this is 9. Or if you don't want to do that, then what you can do is this line is basically x equals to 0. So when x equals to 0, and then y will be equals to 9 minus 0 squared, which gives you the y is 9. So we know that the limit is from 5 to 9. So about y-axis, basically limit 5 to 9, and then this is dy, right? So we are going to write x squared then dy equal to, so 5, 9. So what is x squared? So y equals to 9 minus x squared. So x squared is basically equals to 9 minus y. So 9 minus y dy. I can start to integrate 9y minus y squared over 2, 9, 5. Then now I can start to substitute. So 9 times 9 minus 9 squared over 2 minus 9 times 5 minus 5 squared over 2. So you can count it by yourself. Then after that you will be getting pi 41 over 2 minus 32 1 over 2, which will gives you the answer 8, pi for number A. Okay, so now let's continue with the B part. So this one is the same thing, but it's going to be rotated at the x-axis. Okay, so rotated at your x-axis, so meaning it's going to be rotate like this. But the problem here is we are not including this part, because when we try to do the limit, right, it will be like from the 0 part here, and if this is rotating, then meaning that our upper limit will stop here. So what is the number that we need to put here so that we can find out like which is the area that we need to minus off? So we need to find out this value first. So you can see there's a point here which already give you the y is 5, so we can find out what is the x. So y equals to 9 minus x squared. So since the y is 5, so 9 minus x squared, so meaning x squared equals to 4, which gives you x equals to 2. So we know that this is 2. Okay? So when we do this, right, so it's the same thing. Go back to the area, the concept of the area between a line and a curve, then we can do the exactly same thing. So but it's okay, you just like use your common sense to find out like how to find this. So normally when we say that this thing is going to rotate and we don't want this part, right, it's basically like we rotate this one, then we minus off what is rotated here. So what can we do here? So we have 2. So this is the bigger volume, right? So when it rotate, of course the volume that you rotate for the whole thing is bigger than only this thing. Okay, so meaning that we have a limit 0 to 2, and then rotate your x-axis. So it's going to be y squared, sorry, pi y squared dx. Okay, and then minus off, this is the first one, so which maybe we write down that first. So 0 to, so your y square is 9 minus x square square. Okay, so this is basically for the whole area here. Okay, then after that we need to minus off this area. So what then, meaning minus pi, and then the limit is still the same, right? 0 to 2, and then y square dx. But the y square is different here. So what is the equation for this horizontal line? So this one is basically y equals to 5. Okay, so what is y square? Is 5 square lah. Okay, dx. And what you can realize here is, right, this is v. Okay, so what you can realize here is that you see we have the same pi, then we have the same limit again. So from the few formula that we have learned previously, then we can try to combine these two. So pi 2, 0, Then after that, what is this? Then 81 minus 18x squared plus x4 minus 25 dx. So we combine them together, pi 2 0. So 81 minus, so we try to rearrange everything. So x4 minus 18 x squared, 81 minus 25, we are getting 56 dx. Okay, then after that we can start to do integration. So x5 over 5 minus 6x cubed plus 56x 20. Okay, then now we substitute 2. So the other one will be 0. It's totally okay. Okay, then after that, when you find it, then you will be getting 72 over 5 pi. Is that alright? Okay, so this is how you get to this answer. Okay, let's try the other one. So I find this is quite interesting, so just to share with you. So it's not necessary you want to use this, but if you want to practice this, then of course you can use this. Okay, so the same thing I want to talk about the B part. So instead of using this method is like totally integration, then what we can try to do is we use the formula for solid geometry. We need to make sure that this is a solid geometry that you know, like meaning that you already confirm like it's a cylinder, or you already confirm like it's like a cone, or like it's a sphere. So if it's something like this curve and this is the volume, right, we cannot sure that whether it is really a hemisphere or not, then you better not use this method. But yeah, just to share with you. Okay, so instead of finding, we are still doing the same thing. So meaning that for the volume, this part, right, V equals to, so the big part is still going to be the same, meaning the first part. Okay, but then what I'm trying to do is the second part, which the part that you minus off. So you can imagine this rectangle, when you rotate, right, actually what shape you are producing. So meaning you imagine like this is a curve, so when you rotate, then you get something like this. But if it's a straight line, when you rotate, you are actually getting something like a cylinder. So like, if I were to draw this out, right, this is my line. So imagine when I rotate, I'm actually getting a cylinder. So for this cylinder is the volume that actually we want to minus. So instead of doing integration, then what I can try to do is I use formula for cylinder. So formula for cylinder is like pi r square h. So pi r square h. Okay, so next one I'll try to do it, solve it like normal. I'll be like doing this quickly. So x2 minus x4 dx. Okay, minus pi. Okay, so when you look at this, right, your r is actually this part, correct? So how to find the r here? So it's basically the height. So since y equals to 5, meaning the radius that you are finding is like 5. So 5 square. And then what's your h? Your h is the height for your cylinder, right? So your height is actually from here to here, so which is 2. Okay, so equals to, then I'm starting to do the integration again. So square, then I'll get 50 pi. Okay, equals to, then you continue to solve this, substitute 2. Then after that, you will be getting 1202 over 5 minus 50. Sorry, you have a pi here, then this one you also have a pi. So when you minus off, you are getting 72 over 5 pi. So which is exactly the same answer that you are getting here. But this one is you use the full integration to find the second volume. But for this one, you are using the formula for cylinder to do this. But you just make sure that if you want to use this method, you must make sure that it's like a straight line, yeah, it's like a straight line, then you can make sure that it's either cone or it's either cylinder, then only you can use this method. So for anything that you have a curve, then please try not to use this, because you do not sure that whether it's standard solid geometry or not. Okay, so later on we'll be finishing like we have like 2 more example here. Okay, so we are going to settle 2 more example here. So example 3. Okay, find the volume when a shaded region is rotated through 2 pi radian. So no matter you see 2 pi radian or 360 degrees, is going to be the same thing. So yeah, don't need to worry about that. And then it's rotated about x-axis, then about y-axis. Okay, so maybe start with the x-axis first. Okay, rotated about x-axis, meaning it's going to be like rotate like this. Okay, so what happened here is the same thing, so we can try to analyze like what is the limit for our region here. So it starts with the 0 here, which is quite obvious. Then after that is actually end here, so meaning this is our limit, which is 1. Okay, so meaning like from 0 to 1 for this line, and then when I find the line, the volume for this one, then after that I will minus with the region when the curve here is rotated to my y-axis also, so it's going to be like minus also. Okay, so let's try this out. Okay, A. Okay, so meaning the first one, the bigger volume here. So normally, like, I mean, of course you can see like which one is above, which one is below, but a more appropriate explanation will be like use the bigger volume to minus the smaller volume. So like in this case, you are using like this line, the volume that produced when you revolve this line, and then after that is like with the curve itself. Okay, so now meaning your first one will be like from 0 to 1, and then it's going to be dx, so y square. Okay, then minus off the same thing for the other one. Maybe we write down first. Okay, so both is from 0 to 1, 0 to 1. So the first one, which is the bigger volume, is produced by this straight line. So what is our y square? So since 3x plus y equals to 4, meaning y is equals to 4 minus 3x. So 4 minus 3x square dx minus 1, 0. So the curve here, which is from here to here. So since y is equals to x cubed, so meaning it will be x cubed and square. Okay, so dx. Then now we can try to expand it. 1, 0, 16 minus 324x plus 9x, and then minus 1, 0, x 6 dx. Okay, sorry, I think we forget something here, which is the pi. Okay, but I think here you can realize that you are actually having the same limit, so we can combine them together by writing this. Okay, so meaning we are combining these two together since they have the same limit, same lower limit, same upper limit. So when we combine them, we will be getting this is square. Then we will be getting negative x6 plus 9x squared minus 24x, and then plus 16 dx. Okay, after that we can start to do our integration. 0, 1 negative x7 over 7 plus 3x cubed minus 12x squared plus 16x dx, and we substitute 1. Okay, then remember to check when you substitute 0, are you getting, and you need to check when you substitute 0, are you getting the 0 here? So for this case, everything substitute 0, you are getting 0, so it's okay. Okay, so when you add this up together, then you will be getting 6 over 7 pi. Okay, so that's for the A part, which is pretty easy. So basically they are having the same limit, so we can minus them together. Okay, so for the B part about y-axis. Okay, so for this y-axis, right, then we're going to draw it again. So like it's going to be rotate here. Okay, so when you have something rotate there, then meaning that when you check the right for your limit, what you can realize here is for this line, it's either what you want to do is if you use the whole thing and you want to minus off, and you will realize that what happened is like this. Okay, like you look at this line. Okay, so if you take the limit from this point to this point and later on you want to minus off here, is that possible for you to do that? Because this is basically still under this line. The curve, the area between the curve and the y-axis for this curve is going to exist here. So we cannot like use this straight line to minus off this area because we can't find that area. So for this case, something special is we need to cut it like this. So instead of doing minus, we're doing plus. So this is our first volume. This is our second volume. Because if you want to use the big one to minus off here, we can't find the volume for here. So what we're trying to do is we find the volume that rotated here. Then after that, we try to find the volume rotate here. Okay, so the same thing, I will try to do B. So for this case, it's going to be a plus. So pi, then we need to find out what is the limit here. So this is basically 1, 0. And then for this straight line, so y equals to mx plus c, you will be getting a 4 here. Okay, so meaning for this straight line, so it's going to be x squared dy, and then the straight line here, the limit is 1 to 4. Okay, this is for the v1. So for the v2 part, is going to be 0 to 1, and then x squared also. Then what is the line here? So since y equals to x cubed, right, then meaning y is 1 over 3 equals to x. So if I want x cubed, if I want x squared, then it's going to be, okay, maybe write down x squared first lah. Okay, pi 4, 1. Okay, so x squared. So for this part, so when you want to find x, it's going to be 4 minus y divided by 3. So 4 minus y divided by 3 square, then plus pi 1 over 0. So x squared, meaning that x equals to y 1 over 3. So meaning when we change to x squared, then it's going to be y 2 over 3 dy. So what you can realize here is for this one, right, you have actually two integral with different limits. So one is like 1 to 4, the other one is 0 to 1. So in this case, you can't combine them together because they have the different limit. So you need to solve this like separately. Okay, so if I continue to do this, then I'll expand it. So yeah, I'll straight away write the last part. So 1 over 9 pi 4 pi, you can expand by yourself, minus 8y plus y squared dy plus, so pi, this one, it's okay, we wait for here, then we do it together. Okay, then now I can start my integration. Oops, I'm sorry. 4, 1 plus pi. So 2 over 3, when you minus 1, you get, when you plus 1, you get 5 over 3, and when you divide, you get 3 over 5y, 5 over 3, and then 1, 0. Then you substitute and so on. The first one, you will be getting pi. You try to do the process by yourself, okay? So you are getting pi, then after that the second one you'll get 3 over 5 pi. So when you add it up together, you'll be getting 3 over 5 pi. Okay, so that's for the B part. So the same thing I want to talk about, like the example 2 just now. If you want, you can do it using the other way also. So for this case, it's not going to be cylinder. So you can see for this one, right, this straight line, when you try to rotate it, so what is the thing that you are actually getting? Okay, so maybe you try to draw it up. Okay, I'm going to solve this one, then later we plus it, then you can see. Okay, so we are looking at this line. Okay, so let's say it's this part, right? You cut it here. So this is the region that you want to find. You imagine this thing going to rotate, then actually you are getting something like this, then you rotate. So you are actually getting a cone. So instead of using this to find, then you can use the formula of cone to do this also. So like, let's say, use the other color so maybe you can look at it like clearer. Okay, so like for this one, I have this cone here. So what is the formula for cone? So basically this is V1. Okay, so for cone, then we have 1 over 3 pi r square h. 1 over 3. So radius is here, right? So what is our radius here? So it's basically 1. Then what's our h is basically this. So meaning from 1 to 4 is actually 3. Okay, so when you times it, then what do you get? You get a pi. So you can see for V1, you are still getting a pi. So after that, you use the pi to plus 3 over 5 pi, then you are getting to the same answer. So meaning for the V1 part, if you don't want to use integrate, then what you can try to do is you can draw a cone, then after that find the volume of your cone. Okay, so that's the part for example 3. So move on to the last question. Okay, find the volume generated by the shaded region here. Okay, so I think this one is pretty easy. It's just that, yeah, you need to understand the concept lah. Okay, so if you want to find this volume is actually rotated about x-axis. Okay, then what you can see here is you have also 2 lines here and the shaded region there. So the limit here is quite quite obvious here, which is like from this point to this point. And what do you need to do if you want to find the volume for the shaded region rotated here? Then you are going to use the big volume to minus the small volume when it rotates. So meaning we are still going to use minus, and what you can realize here is they have a different limit here. So pi. Okay, so V1, maybe we start from the big one. Okay, so pi, and then after that we need to find the limit. So y equals to 2x plus 4. So what is your intercept for your x here? So when you substitute 0 here, you get 2x plus 4 equals to 0. Maybe we do here. Okay, 0, 2x plus 4. So you can get 2x equals to -4, which gives you x is equals to -2. So this is -2. Okay, then after that, for your first one, meaning that your limit will be from -2 to 0. So -2 to 0. And then this is rotated about your x-axis. So it's going to be dx, so y squared. Okay, this is for a big one. So minus of the small one. Okay, so again, what is the limit here? So you need to find out x squared equals to x plus 1. If y equals to 0, then what's your x? So it's basically -1. So your y-intercept here is 1. So are you going to use this or this? So you are rotating about x-axis. So that's why you are using the limit from -1 to 0. So -1, 0, same thing, y squared dx. Okay, equal to, start with the straight line. 0, -2, and then y square is basically 2x plus 4 square dx, and then minus pi 0, -1. So y squared here is x plus 1. Okay, because the question you already give you y squared equals to x plus 1, so you don't need to do anything about that. Then try to expand it. So 4x squared plus 8x plus 16 dx minus pi 0, -1 x plus 1 dx. Okay, and what you can actually realize here is that like they have the different limit also, so that's why you cannot combine them together. Sorry, the pen has no ink, so I need to change to this. Okay, then after that you can start to do integration. So 4 over 3x3 plus 4x squared plus 16x 0, -2 minus pi. So this one is it, x squared over 2 plus x and then 0, -y. So now you can start to substitute your value inside. Okay, so can you try it out yourself? So, but yeah, remember this, you need to sub 0 first then minus, so you do it yourself. Then you will be getting tan 2 over 3 pi for this part, and for the second part you are getting 1 over 2 pi. So when you plus them together, you are getting tan 1 over 6 pi. So it's the same thing I want to talk about here. So if you don't want to do that, then what you can do is, instead of using this one to find the area under this straight line, the volume under this straight line, then what you can do is actually, I'm going to write at the bottom here, so hopefully you can see. Okay, so let's look at the big one. Okay, so you have a line like this. So when it rotates, right, you will be getting like here, like rotate. So you'll be getting like this. So it's the same thing, it's going to be a cone also. So this is your R, then this is your H. Okay, so 1 over 3 pi R squared H will be equals to 1 over 3 pi. So what is your R? So your R is the value like here. So what's the value here? Is like from 0 up to this point. So this point is like the y-intercept here. So this is 4. So 0 to 4. So that's why your R is 4 square. So your H is like this part. So it's like from 0 to -2. So that's why 2. So 1 over 3 times 16 times 2. Sorry, you have a pi here. After that, you are getting 32 over 3 pi, which is exactly tan 2 over 3 pi. So this is how you get to, this is how you get to this. So it's like the same with your V1 here. So it depends on you which one you want to use. You want to use the integration method, or you want to use the solid geometry also, is totally fine. But it's just that you need to find out your R, your H yourself, and you need to make sure that it's a standard solid geometry. Okay? So yeah, with this we end our chapter 9. So hopefully you can understand everything. If you have any question, then we will see each other for consultation hour tomorrow. Okay, thanks so much for watching this. So have a good night.